let's continue what we were discussing on the optional maths. If you have gone through my last class, then we were discussing about the functions there. So today I will write some notes about the functions that we discussed on the last class. That was inverse function. So I described inverse function. I described in what condition the inverse can be calculated. So now let's make a small note so that will help you on your examination. So the first question here is, we are defining inverse function. Number I, inverse function. Inverse function. So you can also make a note by writing what is inverse function. I am writing the definition here. So please write in the copy, write in your mind too. Remember. So if f is a function, f is a function that defines relation from A to B, then the function which defines relation from B to A is called inverse. It's called inverse function. So I hope you will understand. You are understanding. If f is a function that defines the relation from A to B, exactly how I wrote on the last class by making the mapping diagram. Please remember the diagram from A to B, and the functions that defines the opposite relation is called inverse function, and it is written by f inverse power minus 1. If g is the function, then its inverse is g minus 1. That shows the opposite relation. Okay, so the second important one that we have to make a note on the inverse relation is in which condition inverse of a function be defined. So dear students, if you have again some remember from the last class, I said not all the functions can be given inverse. Every functions cannot be given inverse. That is the important one. This is the important one on the inverse function, and I gave you some example on that class too. So we are just making a small note because we need to write in the exam. Speaking doesn't get the marks in the exam, remember. So in which condition inverse of a function be defined? If the function is 1 to 1 on top, its inverse can be defined. Its inverse can be defined. Otherwise, the inverse of the functions cannot be defined. Please make a note of this one. You are going to write it in the examination. Okay, so now I am going by some examples of inverse functions, and please try in your home, because you have books, you have copies, you have practice book. Try to follow and find the inverse. So if you have copied it, and writing it now. So on the inverse function, the first example Number 1. If f is the functions that defines the order pair 1a, 2b, 3c, then find f inverse. This is the first example how we are writing the inverse here. So f is the functions that defines the relation from 1 to a. 1 to a. X group 1, 2, 3. The second Y group, that is codomain A, B, C, or you can say range also. They are domain 1, 2, 3. Domain. So now we are writing f inverse. So f inverse means the function that defines the relation from Y set to X set. Remember, Y set or output set to input set. That is 1, 2, 3. So its inverse is the answer. Its inverse, f inverse is, now what we wrote in the definition, A to B, that inverse will be B to A. So now we are writing A1, B2, C3. This is the inverse. Remember. So if you are showing in the mapping diagram also, you can show by mapping diagram, that is, this is the given function f 1, 2, 3, A, B, C. This function is f function. Now we are going to present it inverse. Now let's write the inverse from B to A to B, B to A. That is A, B, C, 1, 2, 3. This relation defined is called f inverse. So this is how we can represent the inverse functions in order pair and in the mapping diagram. This is the first example. Now I am going through the second example of algebraic functions and their inverse. Okay, so I am rubbing it if you have copied it. Slowly I am rubbing it. Now example 2. Example 2. If f equals to 2x plus 4, find f inverse. Okay, you can clearly see here the question has represented the function in the algebraic term. Algebraic term. So now we have to use simple logic. Remember, function f, process the input by 2x plus 4. Remember, so if you remember x, this is the input. This is domain set, first set. And when you put the x there, when it is gone for processing, you will get output, that is codomain, range. So here f itself represents range here. So now what we have to do here is solution. To get the inverse, do not forget one thing. A to B means B to A is inverse. So x to y means y to x is also inverse. Remember? So now I am just writing here solution. Fx equals to 2x plus 4. This is the given in the question. Yes, fx, they are same thing. Remember, this is given here. And we also know that fx is also can be said as y, because after the processing of x, it becomes y. So fx and y are same. So what we can write? So y equals to 2x plus 4. y equals to 2x plus 4 because we can write it down. And in the inverse we have to interchange x and y. Interchanging x and y. Interchanging x and y. Now what happens? Please tell me. You can tell me or you can see here. Interchanging x and y. X and y are interchanged. Now y becomes x, 2y plus 4. Please try to look the previous expression and again try to look the new expression. There was y equals to, now here is x is equal to, because in the inverse x and y should be interchanged. Now let's find the y, or x minus 4 equals to 2y, because you know the mathematical rule. Now what it becomes? Therefore x minus 4 by 2 equals to y. Now you can understand how it became, because 2 has been brought to other side and divided. So this y is called now inverse. Therefore f inverse x equals to x minus 4 by 2. So this is the f, this is the f inverse. Remember one thing, you have to interchange x and y, and the y you obtained is called inverse function. Remember, this is the main thing in the inverse. So I hope you understood how to find the inverse function. Like the channel. Thank you.